Logistic regression is a classification algorithm used when the dependent variable or target variable is categorical. Instead of predicting raw values, logistic regression predicts probabilities. The logistic regression equation is the same as the linear regression. Both use the straight line. Linear regression model draws the straight line to fit through the data points, whereas logistic regression model draws the straight line to classify the data points. In classification, we want to estimate the probability of an outcome. That could be 0 or 1. A linear model can give any number from minus infinity to infinity. Sigmoid logistic function transforms any real number into a probability between 0 and 1. Sigmoid function is represented as 1 over 1 plus e power minus z. Here, z is the linear combination of the features, sigma of z is the output probability. As z tends to plus infinity, probability tends to 1. As z tends to minus infinity, probability becomes 0. If z equals 0, probability becomes zero point 0.5. Sigmoid is in S shape, represents uncertainty. Near the center at 0, it says probability zero point 0.5 with maximum uncertainty. As input grows positive, probability tends. Let's try to understand the loss function. The odds or the probability is given as success over trials. That can be written as p over 1 minus p. Taking logarithm of the odds gives us log odds, or also called as log it. It converts probability to be bounded between 0 and 1. Logistic regression assumes a linear relationship between the predictors and log odds, not the probabilities. This way, the coefficients are directly representing how predictors change. In logistic regression, we model log odds linearly. We invert it to get the probability via the sigmoid function. Log loss measures how well the predictions match the reality. Log loss function is described as the outcomes with its respective predicted probabilities. It has both successful and unsuccessful outcomes. If the prediction matches the true value, the cross entropy or the loss would be 0. The cross entropy or the loss would be 0. If true value and prediction do not match, the loss would be very huge and would be symmetric for true value equals 0. Types of logistic regression. First one is binary logistic regression. Here, the outcome has only two categories, either 0 or 1, yes or no. It's like flipping a coin. Only two possible outcomes are possible. Multinomial logistic regression. Here, outcome has more than two categories with no natural order. It's like choosing a flavor of ice cream, vanilla, chocolate, strawberry. No flavor is greater than another, it's just different. Then comes ordinal logistic regression, where outcome has ordered categories with ranking. It's like grades in the exams. Now let's understand the KPIs we use in classification. Accuracy. It is a fraction of correct predictions. It works very good with the balanced data. Next is F1 score. It is a harmonic mean of precision and recall given as 2 times precision into recall over precision plus recall. It is useful when classes are imbalanced. Next is recall. Here, true positive over true positive plus false negative. Here, out of all the actual positives, how many did we correctly predict? It is important where false negatives are costly, like disease detection. Next is precision. It is given as true positive over true positive plus false positive. Precision with P on the left side, all the positives with P on the right side. It is important for applications where false positives are costly, like spam detection. AUC, area under the curve. It measures ability of the model to distinguish between the classes across the threshold. When AUC is zero point 0.5, we consider it as a random classifier. When AUC is 1, it is considered as a perfect classifier. With the log loss, it is used to penalize confident wrong predictions. Lower the log loss, better the model. Some of the crucial assumptions and properties. Every feature should independently contribute to the response. Predictors have a linear relationship with the log odds, not with the probability. Independent variables should not be highly correlated with each other. All the important variables should be included and irrelevant ones should be avoided. It is sensitive to outliers and multicollinearity. Logistic regression models the log odds, not the probability directly.